Hello everybody. Today we'll be talking about how we can configure secure apps across big IP tenants using console Terraform Sync. So here I have on the left hand side we have the HCP console as well as Terraform Cloud and console Terraform Sync. You can also create this solution using the open software or the community supported version of software. So now here console Terraform Sync will look for any updates on the services on the console cluster. So whenever a new service is created or changes in the service happens, the console Terraform Sync will trigger a new event and it will deploy the configuration using Terraform Cloud on the big IP. So here on the right side, you can see that for folks who are familiar with console Terraform Sync, I have the task block here, and the task block define the couple of things here. So first one is the name of the task, which is AS3 tenant app A, description of the task. So we are creating a AS3 application on big IP, and the source. Source is actually the module, Terraform module, and this Terraform module which will be used to configure the big IP. So we'll talk more about this Terraform module at the end of the at that demo. And the provider being used is big IP, and the service which is monitoring is app A. So whenever there are changes to the services, that can be notified to console Terraform Sync, and or console Terraform Sync learns that and then deploys the configuration to the big IP, right? The changes to the big IP. Now, if it is a new task, you can it takes the values from Terraform A TFR files, and the new app is being app can be deployed that way also. Or the existing app, it can monitor for these services, and task it can monitor for the services, like in this example app A, and update the pool members on the big IP automatically. It also deploys the advanced WAF policy on the big IP. So that way it is doing multi-tenant or applications in the multiple tenants on big IP. And it also deploys correspondingly, it also does deploy the WAF policy for each of the virtual servers being deployed, right? So that way it is protected. And then you can, if you want to add new task, actually you can just update this file and introduce new task with new application. Yeah, so here you can see that we have deployed applications, virtual server. So basically we have deployed virtual server app A as well as app B, and those are deployed in a corresponding tenant, right? Tenant A and tenant B. Now, correspondingly, if you go and look, let's say go into one of the virtual server, you can see that we have also deployed a policy, WAF policy, advanced WAF policy for that virtual server. So all this is the deployment has been done through console Terraform Sync and console Terraform Sync, right? So you can see that you do have the on the console. You can see that my app A and app B has been deployed, and there are two instances of app A and app B, and this is my console Terraform Sync which is registered, and this is the service which monitors the console Terraform, basically console cluster. And whenever these services are added or more services are added, the console Terraform Sync will go ahead and uh, push the configuration on big IP and update the pool members accordingly, right? So for example, you can see that my pool members have been updated to members, like there are two members here, right? So similarly, whenever these members are increased or whenever new services are being deployed, these pool members will be updated accordingly. And let's go ahead and see um, how let's see how we can increase the number of instances now, and through Terraform, and see how console Terraform sync will update those pool members automatically uh, using AS3. So now okay, now let's go into the app A. So you can see that I have count which is only two instances. So I'm going to go ahead and artificially basically go ahead and increase the instances to 4 and see how it can be updated uh, on the pool members, how it can be updated on the big IP using the console Terraform sync and AS3. So let's go ahead and save this, and I can do Terraform plan. So let's go ahead and do Terraform apply auto approve, right? So I'm gonna auto approve is just not to wait for you to type yes. Okay, so I just entered it. Now let's see. So basically what we are doing is we already increased the number of instances for app A from 2 to 4, and we expect that the console Terraform sync will look at the console cluster for those application and uh, update the pool members automatically, right? So you can see that now we have app A. For app A, we have 4 instances, right? And accordingly, the uh, health check is also working fine. So now if I go back and onto the big IP, earlier we had only 2 members added. I'm gonna refresh this and see what's happening. So here you can see that my 4 app A pool member has been updated to 4, right? And uh, similarly, there is a changes actually detected by console Terraform sync. So you can see that correspondingly on the console Terraform sync, we saw the change detected, right? For tenant A, you can see tenant A has been updated uh, with the details, right? And that's where the console Terraform sync monitors the console cluster for changes in the apps and accordingly update the workspace for tenant A and rolls the configuration, new configuration on big IP. You can also see this on the workspace, like the updates have been done for tenant A. So you can go ahead and see that there was a 2-minute. You can go ahead and see on the Terraform console here, configuration was triggered through console Terraform sync, right? So and accordingly, the big IP pool members have been also updated. Similarly, when the instances are reduced, or let's say if you have done with the application and the load has been decreased, in that case, the console Terraform sync will automatically update for that particular tenant. So now let's look at the console Terraform sync configuration. So here I just stopped this service we were running, Now let's go ahead and open that file and see the console Terraform sync file. So this is the console block where we are defining the console details. Like for example, here since the console Terraform sync is running here on this machine, I am also running a console agent. So I just need to refer to the console localhost, right, to register my CTS service. So that's why we are using localhost here. And then obviously we have to use a token because it has to authenticate to the console HCP or the console uh, hosted solution. And then you have the Terraform driver block here. You can see that I'm using my host name here. My organization name is test organization, and then I have to provide the token to validate to the to Terraform Cloud. Um, then the provider details I have to specify, like for example, big IP as well as the address of the big IP, username and password. So I can also pass this as an environmental variable as well, right? And now finally, this is the task, right? So like we saw, we have like the tenant A workspace being created automatically through this task. And this is the module which we are using. So this is the module which takes care of deploying the WAF for the application, as well as it deploys the big IP virtual server as well as the pool members uh, details. And then here the services uh, is where it looks for the service which is running on the console cluster. So like we saw, we had app A been running on the console cluster, and that's what it is monitoring the service. So whenever it sees app A service on the console cluster, it will execute this task and deploy the um, configuration on big IP, wherein it will update the pool member and so on. So this is for app A. Similarly, we can do it for app B and so on. Now, if you need to deploy a new application, what you need to do is actually define a new task, and you can create a new task here and start putting details for the new task. For example, you can put details like what type of service you are deploying and what type of service it has to monitor and push the configuration accordingly. So new task can be given here as well. So all this is available on the GitHub. So you can go to this GitHub page and do a git clone. You can pretty much deploy everything, like basically app A, app B, the F5, as well as if you see the configuration here, so I can share that with you guys. So you can go ahead and look at the script here, and this is how we are basically registering a new service. Um, and then if you go down below, you can see that the definition of the driver, Terraform driver block, as well as the console block is shown here, uh, as well as the Terraform provider and the task which are used. So pretty much all this you can create it in the startup file or in the setup jump.sh file, and that you can define in the instance itself when you are deploying the instance. So that way you don't need to create anything new. So whenever you get clone, actually you can pretty much do all this, which will be done for you actually on the instance itself. So let's look at what module we are using, right? So this is the module which is already registered, a console sync multi-tenant. And if I click here, actually I can go to the module. So let's look at the template first. Sorry, this is not. Yeah, let's look at the template here. And this is the console webinar YAML file, which is the template. This is nothing but the fast template which we are using for this solution. Okay, so this is nothing but the fast template which we are using. So here, the initial part of the template, this is the console service discovery template. The initial part is the definitions. Like for example, for the fast template, you have tenant name of the tenant where your application will be residing on the big IP. Then your app, your virtual server will be the tenant, right? Virtual server as well as all the application objects will be on the tenant. Then your app, what is the name of the app? So that you have to define. Then the pool name, def pool is the pool name. Then the virtual address and virtual port, that is the virtual IP as well as the virtual port. And finally, so once you do that, actually, then you have the actual parameters which will be defaulting to these values, right? So you can define those. Like if we don't specify anything, then it's going to take these values when it is rendering the template. So now let's look at the template. So this is the AS3. So fast template is nothing but an abstraction to the AS3 itself, right? So you expose, so instead of focusing on all these parameters, it's best to, look at only these couple of things, right? So the developer or whoever is deploying the application, he just need to look at just provide these details instead of looking at the whole template. So here, so we have templatized it. So you can see that the tenant has been introduced into double quotes, double curly braces. That means this tenant will be replaced by the actual tenant value when the template is rendered, right? And then similarly, you have the apps, which is templatized and so on, right? And then finally, we have this policy, which is the WAF policy. So now this policy can be locally available or it could be stored in your Vault or any other secured place as well. So in this case, I'm just putting this on a gist link here, gist repo on the GitHub. So here you can see that the policy name is specified, a description of policy, what it is doing, then what server technology I'm using, like things like MySQL, MongoDB, and so on, and also like enforcement mode, which is blocking, right? So these are some of the things. So this can be given locally as well as I said, it can be placed anywhere, and you can define that in a URL as well, right? So that's it. And so here you can see that I'm referring to the gist where the policy is on the Git repo. And then finally this address discoveries event. So that means it's going to use service discovery, and depending upon the event which is happening, it will discover the services which are there, uh, and react to that accordingly, right? So let's look at so we already saw the template. So this template we will be using in the repo or in the module. Then finally, this template will be used in the module. So now let's look at the variables. So variables, you guys, if you are familiar with console Terraform sync, so these are the services variable for the console, which console Terraform sync uses, the services variable. And this defines the different things about the service, like for example, name of the service, address, where it is running, the port number on which it is listening, the status of the service, metadata, some metadata, like things like your namespace, it is in a specific namespace that can be defined. Then the node ID, node address, node data center. These are all the console parameters or the console variables which can be used. And then finally, these are all the big IP variables which we are defining, like the address of the big IP, port, username of the big IP, whether it is admin or any other user, password of the big IP, then the tenant. So these are very specific to the application being deployed, right? So tenant where on the big IP where my application objects will be residing. Uh, so it is, if you don't specify anything, then it will take this as a partition and deploy it in this. The name of the app, currently the default is nginx, but you can have your own services and it will pick up whatever values you have specified. And then def pool, this is the one which is defining the pool name. Now this has to follow a certain rule. So basically make sure that it always go with the app name underscore and pool, right? So this will talk about why this is required, because when you are dynamically removing the nodes as well as adding nodes, this is what it is going to refer, right? But it can be anything here. It can, the name of the app can be anything, but this part remains same. So that's the thing which you need to consider. And then finally, the virtual address and virtual port, which you can define in your configuration. So now let's look at the main.tf. This is again the part of the module. So here you are defining the Terraform provider. In this case, we are using big IP provider, and this is the locals. So locals are the variables which are used for different tenant as well as for different apps. So if you are deploying multiple apps, that's where, if you are deploying multiple apps on multiple tenants on the big IP, these are the parameters which you need to consider, right? So where.tenant, then your app name, again your virtual address, your pool name which you talked about, then your virtual port. So this is the locals definition. Here actually you define the create the zip file from this YAML. Now why do you need a zip file? Is basically we want to upload that template. So we want to zip it and basically upload that to the big IP. And so that's what we are doing here right now. So it will do that. So it will automatically upload the upload the template there, the fast template on big IP. Means it will zip that fast template, and here actually this is the resource where it will upload that onto the big IP. This resource will do that. So it will take the zip file and upload it. And then finally, this is where it will render the template, right? So now we already uploaded the big IP template. Now what we can do is use these local parameters, which we have defined in the tenant params, which we have defined here. And you use those local, take those values from those variable values, and then render that template, right? So if you have different applications and tenant names as well as app names, that can be fulfilled with this particular resource. And then finally, this locals actually talks with yeah. So here these locals is specific to the uh, console services. Like you can what we are doing is actually all the service ID we are storing in s.name, and then we are grouping those service ID with the name as well as ID. Why we are doing that is actually so we wanted to use these locals here in the big IP event service discovery resource, so that can go through that stored values, and for each value. So basically, we want to create a configuration on big IP, right? So we want to push the pool members, configure the pool members through these values. So here you can see that the task here is the resource ID, resource Terraform resource big IP event service discovery, and it is going through local dot service ID, which is your locals dot service ID, and where all these services IDs are stored in this s.name. So we are going through that array, and then we are also going through the local dot group, which is this particular grouping with name and IDs, right? And those names and ID we are using in this particular resource, big IP's event service discovery resource. So here, one of the important thing which I need to point out is that the task ID is nothing but the API which is created dynamically for with these values, right? So with tenant, with those tenant name, with the app name, and with the pool name, it creates a unique API endpoint, so that this resource, big IP service event service discovery, can use to configure the big IP services, right? So whenever new service is there registered, it will basically use this particular value to uh, configure the uh, pool members. And whenever the services uh, are gone, it can also, this resource can also remove the services automatically. So this is actually depending upon the service events, right? Which we talked about. So this is pretty much it about the module. The module is already out, and you can pretty much deploy multiple services. Like for example, if you go here and look at the task, so those tasks can be defined and you can create multiple services, right? In this example, you have tenant A and tenant B app which have been deployed, and accordingly you can go ahead and configure more services.